Okay, Rugose corals, part 2. So Rugose corals undergo a development. The development has names for the different stages. So the larval form is what's swimming around, and that would not have any skeleton. But later it's going to settle. That's the process of sticking to one spot, and it's going to start to grow its cup. And so at that stage, we're calling it the brephic stage. And the brephic stage is when it's going to start to develop septa. At first, there's an empty cup, and then it puts septa into the cup. And the first septa are going to be those protosepta. So if you get your coral early enough and section just the bottom of it, you will see counter and cardinal and 2 alars, and that's it. So after that, it is going to start adding septa either side of the cardinal septum and rather on top of the alar septa like normal. That's going to be adult development. In some corals, but not all corals, you can recognize an intermediate stage where it's kind of between brephic, it's doing something weird, and now it's into neanic, or where the cup is like flaring, and then suddenly when it's doing adult growth, it's going to go straight. That's fine, and if we need a word for it, we can put neanic in, but not all coral fossils will have a visible neanic stage. Same thing with gerontic. Once we're done adding septa, that's kind of the end of the adult stage. And then if there is further development, if something changes, then that would be called the gerontic stage. And so there you go. The other thing that Rugose corals will do is rejuvenescence. And rejuvenescence is when the coral will shrink down and it will start to regrow its skeleton. It's like it's going through its development again. But when it does rejuvenescence, it skips the brephic and it goes straight to the neanic. So if you can't identify a neanic phase, objectively, you can say that, well, the point at which it is doing rejuvenescence, which is right here in the one that's on the screen, is effectively what the neanic phase is. All right, so here are some corals. We're looking at the little tip, the distal end, and these are showing how the corals would attach. So the larva is going to attach to something that's bigger and harder, or at least it's going to try to. The coral larvae are not always completely selective, and probably a lot of them die from bad choices they make in their youth. But here you can see a couple cases, A, C, and E, where it's attached to different kinds of bryozoa. That's adorable. B, I'm not sure what it's attached to there, but in D, it's grasping a little bit of nothing. I think there may have been something like an algae stem there at one point. And then when the baby coral continues to grow, these are just the bottom little tip of these corals, and the adult coral can dwarf the thing that it was attached to, or the thing that it was attached to can just be organic and can go away, and that's fine. The coral breaks its host. The coral isn't actually leaving, but the host is shattering maybe, and then it goes on with its life just like that. So you can see in these what the brephic corallum looks like. And so that would be image 3 and 4 up there. You've got an empty cup, and this is before the first septa are put in. This is truly like early stage brephic coral. In 2A, you can see one that's actually gone through brephic and the start of neanic development, because it's got those little ridges on the side are septa. Because remember, septa start small and then they grow big, like everything. Over here you can see one that's doing a bit of rejuvenescence, or is maybe growing off the inside of a cup of something else. That's kind of cute. But you can see on the outside there's a real difference in the way the cup looks at the different growth stages. So your true brephic is probably from here down to the tip. This is probably your early neanic. This is like your late neanic up to about here. And then it's undergoing metamorphoses, and it will turn into the adult form. So yeah, little corals like just think of it as a shell that grows in a particular place and happens to sometimes stack up enough that it makes reefs. They're just another little shell. And then animal living inside of it. Now, you can sometimes read on the outside of these. It's only on certain kinds, but you can read the order of the septa, and you can tell where you are. So looking at 2B and 2C, you see the red and blue arrows there. The red and blue arrows are, let's move these down, are pointing to, there we go, are pointing to, the red is for the alar septum and the blues are for the new septa that are coming out of it. Like, look at them branch out from there. And since they're only branching out from one side, that's how you know it's an alar septum. Yeah. Going forward, compare that to image 10, the one at the bottom here. The alars are above, and this is a cardinal septum. And you can tell because look at all the little septa that are branching out from this point. There's two more right there. And so this would be some component of either late neanic or adult development, most likely. And so these developmental stages have to kind of be defined for each, maybe genus of corals, possibly for each species of corals. All right. So a note on rejuvenescence. So rejuvenescence is going to involve using the skeleton again. The skeleton is going to be continuous between the old and the new, and there's two different ways that this can be triggered. One is by damage to the corallum. You can see there's a big chunk out of this coral right here, and we've grown back actually from the side that was damaged. I don't think there's any rhyme or reason to where it grows back. But as it grows back, it's going to go through its development, but missing out the brephic. It's just going to start at neanic and then go up to adult again. With real rejuvenescence, like more the thing that you would think about, here we are, and you see the coral is going to contract. And so this is likely because of something in the environment, but oftentimes we don't actually know that this was the case. But it's going to contract, and then it's going to basically regrow from a smaller version of itself, like a smaller footprint. And there's